Assalamualaikum and hello to our beloved lecturer, Madam Musna. So today, my name is Aiman Mohidin. So today, me and my team will present about the design, trajectory of a multilateral well and compression system. So the presentation will be divided into the four sections, which is the first, introduction, section A, which is include the case study, calculation and discussion. The third is section B, also in case study, drawing and discussion, and lastly conclusion. So let's start with the introduction. For introduction, so in this modern era, inventive analysis is crucial to overcome the obstacle experienced by the oil and gas industry in regard to horizontal well drilling. Currently, the industries are facing many challenges regarding the well and operating areas. The multilateral well technology has shown to be effective and to give a superior answer in terms of both production and financial considerations. Next, multilateral well systems are widely employed in the oil and gas business due to their efficacy in providing a superior well approach as well as oil and gas reserve. Nonetheless, the multilateral well system goal is to effectively boost hydrocarbon output. Besides that, the application of multilateral well from deep water to Arctic, from tiny well to mammoth well development field predicted that the multilateral well system would would drive itself to become one of the leading production technologies. So for the last point, multilateral agreements have been confirmed by their economic performance and capacity to save profit and time while increasing oil and gas output. I will pass the presentation to my team. Thank you.
Hi, my name is NATASYA MUSAIDI and I will continue on the next section, which is section A, literature review. So for this literature review, there is 3 case study that we discussed in the report. So the first case study is about article 1, production behavior analysis of multi-branch horizontal oil well considering reservoir and well type factors, and article 2 is the productivity index of multilateral well, and article 3 is the endpoint model for optimization of multilateral well placement in hydrocarbon field development. Next, we will continue on the calculation part on the same section, which is section A. So in this particular segment, which is calculation, we only focus on the stacked multi-branch well, but in the report there is also 2 other multi-branch wells such as EN3 and also custom multi-branch well. But since we are running out of time, so we only focus on stacked multi-branch well, because in the discussion later on, we only focus on stacked multi-branch well also. So this is the data given for target 1, target 2, target 3. So there is target vertical depth there, local north-south in feet and local east-west in feet. So the other 2 table here is about the data we assume for stacked multi-branch well. So for the surface coordinate, we put there 0, 0 for north and east because it is easier for us to calculate for the next calculation, next as working. So next, about the build out rate, we consider 2 degree as the typical and most common use in the build out rate. Next is the kick-off point VB. Here we put there 2,000, 6,000 and 11,000 because it is in between the target that we select. So like it is here and here. So next is the summary of well position for stacked multi-branch well. From the table 1 and table 2 we summarize, and here we get the summarization. So next, moving on to the next part, Mr. NAQEEB.
Assalamualaikum, my name is Muhammad Aiman. I'm going to continue the presentation with our discussion. What does everything that we calculated and everything that we have done till this point, what is the conclusion of it? So basically, my discussion for section A consists of these three approaches that we can make in order for us to achieve that target. So the first one is stack multi-branch well, the second one is cluster multi-branch well, and the last one is E-entry lateral well. So what is the difference between these three? As you can see, the difference is in the origin and the KOP. Basically, all of this well uses different concept in achieving the same thing, which is achieving multiple targets at the same time. So for stack multi-branch well, the origin is 0, 0. And why so? Because the origin for stack multi-branch well is crucial because it uses the concept of going the same way. Basically, all of our target have about the same longitude and latitude, which is negative. So stack multi-branch well need a point where all of the target is now facing the same way. And with that being said, 0, 0 is a good start because it will now be easier for stack multi-branch well to achieve the target without any hassle. Okay, the next one is cluster as well as E-entry. Their KOP, their origin is -1500 and -150. This is due to the fact that they don't need that one facing direction. They only need just a place for them to drill, and they have a more diversified direction for it to achieve the target. And then the KOP for stack multi-branch is 2000, 6000 and 11,000. For cluster, however, it only have one KOP because it only needs 1 point before it branches out and diversifies. With everything that I've said up to this point, our conclusion is we decided to use stack multi-branch well in order for us to achieve the best and efficient drilling towards our target. So basically, as you can see, we've plotted the spider plot for all the three, and the best viable option is using stack multi-branch well. As you can see here, this is the graph for cluster well, and this is for E-entry. So we can conclude that stack multi-branch well is the best viable option because of the case study that we've done as well as the graphs that we've done, and we already know the direction that we are going with the whole stack multi-branch well. So that's it from me. Thank you very much. I'm going to pass it to the next presenter.
For the literature review for this section, it is based on the article, which is Article 1, 2, and 3. Article 1 titled An Integrated Approach for the Planning and Completion of Horizontal and Multilateral Wells. This article talks about DAML that classified the multilateral completion based on the amount and type of support provided at the junction. It also talks about the factors, which are completions requirement for both the main bore and the laterals, the junction integrity requirements, the lateral and the main bore re-entry requirements, and lastly the production requirements. Next article, which are Article 2, titled An Overview to Applicability of Multilateral Drilling in the Middle East Fields. This article says that many operators in this region saw multilateral drilling technology, TAML Level 3, as the natural progression from horizontal drilling technology. Since 1992, the Middle East has experienced substantial increase in the usage of multilateral drilling technology, to the point that the region is now one of the most active in the world for multilateral application. Saudi Arabia, the United Arab Emirates, Oman, and Qatar have all made significant investment in multilateral technology. And for the last article titled Innovative Approach for Multilateral Well Completion with TAML Level 3 Junction Installation in Open Hole. This article states that extended lateral drilling of a multilateral well increases the contact area with the formation and, as a result, the well's production rate. The widespread usage of TAML1, the TAML2 is limited by restriction reduces the effective lifetime of such a well. Multilateral well completion in the open hole with TAML3 joint installation while retaining mechanical integrity with the potential of selective access to both lateral during further downhole operation without usage of additional service equipment. Moving to the discussion. To proceed with the project, a certain level of TAML needs to be selected, and based on the studies that we conducted, the usage of TAML level 1, level 2, and level 3 has been chosen. Using these three TAML, we can enhance the productivity, increasing the efficiency of the fluid flow, which will give you the most yield, maximizing the profit being made by the client. As seen in the slide, each of the TAML have their own specialty, and each of the TAML got their own design to cater the needs of each stratigraphy, and like every design, there are limitations that come with every design. The advantages of TAMM1 that we can utilize is the low drilling cost, which is the best economical option, but the limitation is not suitable for the unconsolidated formation, which make it a loss. In conjunction with that fact, the idea of using level 2 then is being put in fruition, as the usage of TAML level 2 can give more support toward the whole project, as it will use cement at the main bore and give the well better integrity. But it will still not fulfill the requirements being pointed out. It then continues with the usage of level 3, which is in our case is sufficient at this level, give the best support towards the whole wheel. This level does not give you the pressure integrity that we need, but the support that we get from the connection of slotted linear in the lateral, as well as it being anchored to the main wellbore. After extensive research, it is obvious that the best viable option for this project will be TAML3. We expect a reservoir that assists within the formation of water corning, and with that, the best option to use perforated liner, as it is more economical towards the whole production. Thus, the usage of TAML level 3 is still needed to ensure the good well.
Okay, Assalamualaikum. I will now explain about the schematic well completion. So as illustrated in the slide, the completion well is designed by using the well trajectory projection, which is influenced by the formation characteristics as well as each function within the equipment. The design must be as efficient as possible in order to reduce overall project cost, make the project easy to navigate and manage, and be the easiest to maintain in the long run. In this case, we expect the reservoir to exist within the formation of water coning, and the best option is to use the perforated liner because it is more cost effective for the entire production. So starting at the bottom, the wireline anti-ride WEG will be installed as a guide for fluid and tow string re-entry for the entire tubing, and this component will be installed at the very tail of the pipe. It is then will followed by the no-go landing nipple, which serve as the end and lock for the entire plug equipment as well as the tubing plug, preventing the tow string from dropping. Also at the end, a permanent packer will be installed. This is to ensure that the entire assembly receives sufficient pressure seal and also act as an isolation for the annulus, joint and fluid. The function is the same as for single packers that will be installed in the main bore near each junction at each lateral zone. Next, the assembly will then include flow coupling, slide sleeve door, safety valve landing nipple, and surface control subsurface safety valve. And each of these components is located within the assembly to complete the well. Each location may have specific alternative flow, with 3 assemblies containing flow coupling and slide sleeve door located at the upper single packer, while the uppermost part of the well will have assembly 1 that consists of 2 flow coupling and 1 safety valve landing nipple and 1 surface control subsurface safety valve. This is in order to control the shutdown system, and the safety valve landing nipple will protect the robustness and integrity of the hydraulic system in order to keep the surface control subsurface safety valve operational and functional towards the hole. On top of everything, a packer fluid will be installed to ensure that the casing and tubing are properly balanced. A tubing hanger installed in conjunction with a pop joint will complete the assembly by hanging the tubing at the very top and attaching the entire tubing with a short length directly to the wellhead. This will provide mechanical construction and integrity to the entire well. The top will be topped with a Christmas tree, and the type used is a flank type, which is very typically used in an oil well due to the pressure rating being limited to 3000 psi, which is preferable in this particular well. This is because it can easily be manually operated for valve control of fluids throughout the entire well.
In conclusion, based on the present circumstance, the production rate of oil can be improved and increased with the use of longer horizontal section or branches. The multilateral well length will give huge impact on the productivity of the reservoir as well as the financial outcome. Furthermore, the total production can be increased intensely with application of the multilateral well as an option to single horizontal well. The multilateral well also made possible the enhancement of low permeable and heavy oil production rate. By using the identical technology that has been developed for single horizontal well, the multilateral well is possible to be applied widely in oil and gas industry. That's all from us. Thank you.